on Fascinating Frontiers, episode 115 for June 28th, 2026. The universe has been busy. Let's get into it. The week's biggest developments pulled together, what actually moved, why it matters, and what to watch next. SpaceX cumulative orbital deliveries now exceed the total from every other launch provider in history. The gap stems from reusable Falcon 9 first stages that return to landing platforms or ground pads after each flight. No other operator has matched the flight rate or payload capacity achieved so far. The company's Starlink missions continue at high cadence and keep pushing the total higher. Future Starship flights could widen the margin further once they enter regular service. SpaceX is also preparing a disc-shaped re-entry vehicle called the Starfall capsule for a demonstration flight. The capsule is sized to return small batches of materials processed in microgravity. No prior commercial re-entry system has offered routine, low-cost sample return from orbit. Engineers are targeting specific performance metrics during the upcoming test. Speculation continues about whether a payload was dropped from a recent related launch. Estimated splashdown timing for the Starfall demo has been discussed in tracking updates. The capsule is being included in counts of 2026 orbital launch activity, from launch dominance on Earth to what that capability might enable on another planet. Researchers have mapped the measurements needed to judge whether warming Mars is feasible. The plan focuses on releasing greenhouse gases or deploying orbital mirrors to raise surface temperatures enough for liquid water. Key unknowns include how much carbon dioxide remains trapped in the polar caps and regolith. Data from current orbiters and future landers will feed into climate models that test each scenario. The study provides a clear checklist rather than claiming success is assured. While engineers plan how to warm Mars, scientists are still debating whether life was ever there. Discussion threads are revisiting the 1976 Viking lander biology experiments that tested for metabolic activity in Martian soil. The original results remain ambiguous, with some scientists still arguing the labeled release tests showed signs of life, while others attribute the signals to chemistry. Recent posts compare those early data with modern instruments such as Perseverance, Sherlock, and Pexels. Contributors note that sample handling differences between 1976 and today limit direct comparisons. The conversation centers on what a new dedicated life detection mission would need to resolve the question. The same planet that sparks life detection debates is also revealing its deep interior history. Researchers at the University of Oxford have identified signs of enormous Earth-like magmatic systems that once existed deep beneath the Martian surface. The findings challenge the long-held view that plate tectonics are required for such complex geology. Data from orbital instruments revealed layered structures consistent with repeated episodes of large-scale melting and intrusion. These hidden systems would have shaped the planet's crust and mantle over billions of years. Follow-up studies will examine whether similar features appear in other regions of Mars. Curiosity is shifting its focus on Mount Sharp after orbital images showed texture differences in the terrain ahead. The rover will drive a short distance toward a smoother patch identified from orbit. That site may expose mineral assemblages distinct from the rougher bedrock studied recently. Onboard instruments will measure chemistry and texture to check whether the change records shifts in ancient lake or wind conditions. The next planning cycle will decide whether to pause for contact science or keep climbing toward higher strata. Mars is not the only world whose interior models may need revision. New interior models suggest Uranus and Neptune could host hot, rocky magma layers rather than the traditional water-ammonia ices. Voyager 2 flyby data from 1986 and 1989 remain the only direct measurements, leaving room for alternative compositions. Revised equations of state show that silicate mantles under high pressure and temperature could match the observed densities and magnetic fields. The shift would change how scientists interpret heat flow and atmospheric dynamics on both worlds. Future orbiter missions will test these predictions through gravity and magnetic measurements. While outer planet models shift, astronomers are getting sharper views of our own galaxy's center. The Euclid mission released its widest and sharpest view yet of the galactic center in visible wavelengths. The image covers a crowded field packed with stars and dust that ground telescopes struggle to resolve. Euclid's wide field camera captured the data during routine survey operations. Scientists will use the mosaic to map stellar populations and dust lanes across the inner galaxy. Future data releases will add near-infrared layers to the same region. Another telescope is also delivering unprecedented star counts, this time in an edge-on galaxy. Infrared observations pierce thick lanes of dust to map the thin disk and bulge structure of an unnamed edged-on spiral. The census provides a rare side-on census of stellar populations across the full radial extent. This view helps calibrate models of how dust and stars are distributed in galaxies viewed at other angles. Future papers will compare the star counts against simulations of disk formation. From distant galaxies to our own solar system's visitors, a newly analyzed object that passed through the inner solar system last year shows a composition consistent with formation during the universe's peak star-forming era. Spectral data suggests the comet originated in a cold, dense cloud within a stellar system that was ejected early in galactic history. Its ices and dust differ markedly from anything formed in our own solar system. Astronomers are using the object to test models of how planetesimals are scattered between stars. Follow-up observations with additional facilities are planned to refine the age estimate. While ancient objects pass through, Canada is charting its own future role in space. A new analysis argues Canada can expand its role through targeted investments in robotics and Earth observation. The report highlights existing strengths in satellite technology and astronaut contributions. It recommends closer coordination between government, universities, and industry. No specific funding figures are attached to the proposals. Next steps depend on upcoming federal budget decisions. Japan has donated $23.6 million toward Paraguay's first space technology center. The funding will support construction and initial operations of the new facility. Paraguay has not previously operated its own dedicated space technology infrastructure. The donation builds on existing bilateral cooperation in science and technology. Local teams will gain access to training and equipment through the center. Implementation timelines will be set once construction contracts are finalized. Before their flights, Apollo crews practice sampling and traverse planning in Alaska's Valley of 10,000 Smokes. The landscape, shaped by volcanic ash flows, gave astronauts experience identifying rock types and structures quickly. Those exercises shaped how crews later documented samples returned from the moon. Archival photos and audio from the sessions are now part of a new public exhibit. The training underscored the value of field geology skills for lunar surface operations. Space Shuttle Endeavour has been placed on permanent display in California. The orbiter joins other retired vehicles in a museum setting that highlights its flight history. Visitors can now view the vehicle alongside artifacts from its missions. The display preserves the engineering details of the reusable spacecraft design. Planning for the installation drew on records from the entire shuttle program, from national strategy to a quick look at other notable items this week. Researchers have linked specific re-entry events to sudden spikes in atmospheric metal concentrations. The data come from ground-based sampling that captured elevated levels of elements commonly used in spacecraft construction. These measurements show how material from returning stages disperses at altitudes where it can interact with the stratosphere. Follow-up studies aim to quantify how frequently such injections occur as launch rates rise. A satellite tracking tool now includes an option that removes artificial magnification so objects appear at their real sizes. Users can select the International Space Station and watch the view zoom out until the station shrinks to a single pixel against the globe. The update incorporates accurate three-dimensional models for the International Space Station, Hubble, Tiangong, and thousands of Starlink satellites. Real-time propagation still runs on Celes track data, but the visual now matches the physical spacing of objects in orbit. Season 53, Episode 7 of the long-running science series focuses on current lunar exploration architecture. The program covers lander development, surface operations, and the role of commercial partners in establishing a presence. Interviews highlight engineering challenges that must be solved before crews can stay for extended periods. Archival footage from earlier programs is woven in to show how far planning has advanced. One company is exploring whether oysters could serve as biological water filters for future astronauts. The approach would use the shellfish to remove contaminants from recycled water aboard spacecraft or habitats. Laboratory tests have shown promising filtration rates under controlled conditions. Engineers are evaluating how such a system could integrate with existing life support hardware. The concept remains in early development, but could reduce reliance on chemical filters. Keep an eye on upcoming federal budget decisions that could shape Canada's next moves in robotics and Earth observation. That covers today's space and science news. Share this with a fellow space enthusiast if you found it interesting. I'm Patrick in Vancouver. See you tomorrow. And if you'd rather watch than listen, find us on YouTube at NARA Network. Links in the show notes. And before you go, this show is part of the NARA Network, a family of daily podcasts on tech, science, and markets. Each one a short, sharp briefing you can finish on the commute. If today earned its place in your feed, here's your next listen. Modern investing techniques, modern strategies for Canadian and US investors. Find every show free at neuronetwork.com. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.
Drifting softly